So the first thing that I could ask for that you kind of do before you factored it gives you the horizontal asymptotes, and that's what helps you know your left and right in behavior. So everything else comes from the factored form of the rational function. The horizontal asymptotes do not, and then your in behavior does not. So let's kind of go down to horizontal asymptotes. Asymptote y equals, it's your a over b. So my a is 1 and my b is 1. So 1 over 1. And that's f of x equals 1. The limit as x approaches positive infinity of f of x equals 1. Right. Now with everything else, we need to go ahead and factor. So let's look at the numerator. How does the numerator factor? That multiply and add to 2 and 5. X plus 2, x plus 5. So I know that the x plus 2's cancel. The your zeros, or your x-intercepts, that's what's left over in the numerator. So I have x minus 2 equals 0. And then we get to domain and range, which is what you've not seen for quite a while. And in the domain and range, early on, I kind of started by breaking it down like this. Basically, your domain would be from negative infinity to infinity, but you might have some breaks in between. Those breaks happen at holes and asymptotes. That's where your breaks are. So if I look back, holes, we really actually need to go back and find the y value too. I forgot that, sorry. Let's go back there real quick. So if x is negative 2, I need to find my y value, because that y value is going to affect my range. Okay, so if I go back, my y value for this hole, you plug in negative 2 back into what's left over. So it would be negative 2 minus 2 over negative 2 plus 5. which is negative 4 over 3. Again, you won't always see holes with the x and the y, but you might need it. So I have, here's my asymptotes there and there, and then my hole has an x and a y. So your domain, you're going to have a break at negative 2, because it's x equals negative 2, your domain or your x's. So anywhere that you have a break at an x, that's going to be a break in your domain. So at negative 2 and at negative 5 would be my breaks. And the negative 5 goes first because it's lower, it's less than. So when we write the domain, we're going to have negative infinity to negative 5, close your parenthesis, and then we have our that union symbol, that U. We pick back up at negative 5 and go to negative 2, close that one off, and then we pick back up at negative 2 and go to infinity. So that's your domain. Now your range, we have a break at the horizontal asymptote of 1 and then at negative 4/3. So the negative 4/3 goes first because it's less than 1. So your range is from negative infinity to negative 4/3. Have that break there. Negative 4/3 to 1, and then 1 to infinity. Your zeros, be careful. Your zeros, you might see x equals 2 and try to put a break at 2. Your x-intercepts aren't a break. Only the holes and asymptotes cause you to have a break in your domain and range. Do another one. Just kidding. I thought I had 2 examples there. Guess I don't. Alright, so now I have given you a graph, and you are going to come up with the equation of the graph. Okay? So you need to pick out the holes, the zeros, and the asymptotes. All right. So let's start with the holes. And with the holes, you really only need the x value. Like when you're going back to write the equation, you don't necessarily need the y value. So what's the x value of my hole? 4. At x equals 4. Here's your hole. Right over here, it's x equals 4. So where you have a hole, that meant that you had that factor in the numerator and in the denominator, right? So what factor goes with that x equals 4? Just x minus 4. If you have an x equals 4, your factor is x minus 4. So I'm going to have an x minus 4 in the numerator and the denominator. That out would have given me a hole. What about zeros or x-intercepts? Where does it cross the x-axis? It crosses at 3. So what factor do I need? This is x equals 3. Your factor would be x minus 3. It's kind of the opposite sign. Your zeros, those factors are what's left in the what? Top or bottom? Numerator, denominator? Numerator. So that x minus 3 goes in the numerator. What about vertical asymptotes? That's at x equals 2. So my factor that corresponds with that would be x minus 2. And vertical asymptotes are factors that are left in the denominator. All right. Horizontal asymptotes. What is that? It's y equals -1. Now, this doesn't mean that I have a factor of y plus 1 somewhere. When you have a horizontal asymptote, if it's y equals a number, remember that's like your a divided by b. So my numerator divided by my denominator degree would need, the coefficients would need to be -1. Which really you just want, that means just one of them needs to be negative. Okay? So I'm just going to put a negative there. If it was like -2, I could put like a -2 in the numerator or something. Okay.
So would it be the same if you put negative, just put -1?
I could put a -1 in the front. Yeah, that's fine. Alright, so this looks like it might be correct. We want to check a little bit. Okay. So one thing that we can do to check is think about your whole. So my whole, the x value is 4. The y value looks to be about like -1/2, maybe a little bit more than that. So if I go plug in 4, if I go back here and plug in 4, let's see if we would get a y value that would kind of match where my whole is. And if I do, that means that I probably got it correct. So negative, my whole was at 4 minus 3 over 4 minus 2, which is -1/2. Is that the y value of my whole? Yeah, it probably is. So that tells me that I probably have it right. I could also graph it. Negative x minus 4, x minus 3. Now your calculator won't show wholes very well, or at all. Does that look like it's shaped about right? I mean, the lines are all going in the same direction. So that tells us, yeah, I think we got it right. Okay. Let me look at this NumWorks calculator. Let's see. Let's go to functions. Add functions. Negative, I've not done a lot with this one. X minus 4, X minus 3 over X minus 4, X minus 2. And you can't really see that, can you? Alright, so I'm going to hit, oh. And then let's go up and look at the graph of it. So this one also did not, I thought it would actually show the whole a little better. It does not. But so we still can tell, if you have your calculator, you still can tell, like, it looks like it's shaped about right. Alright, so let's look at this next example. Alright, so whole My whole is at x equals what? 2. So I should have the factor. What should my factor be? X minus 2. And wholes, you have that factor in the top and the bottom. X minus 2. X minus 2. Zeros or x-intercepts. I only have 1. It's at x equals 1. So I would have the factor x minus 1. And that is in the numerator. Vertical asymptotes, we're at x equals 3. So we have a factor at x minus 3. And where does that factor go? In the denominator. Do we have any other vertical asymptotes? There actually is another one. It's right here. You just can't, you don't see the dotted line because of the axis. But you see how the graph, it's like your graph kind of stops there. It stops at x equals 0. So if that happens, you do have a vertical asymptote at x equals 0. It's just harder to see. So your factor is just x, and we usually put that in the front. If you have just, you don't write x plus 0, you just write x, and we put it in the front. Okay. Horizontal asymptote. Do we have any horizontal asymptotes? It is. So you see, this graph doesn't actually, like right here, it's getting really, really close to that x-axis, but this part isn't going over it, which tells us it has a cross through the boundary. So we do have that boundary right there at y equals 0. So whenever our horizontal asymptote is at 0, what does that tell us about our function? Your denominator degree is greater than your numerator. And that is the case, right? I have x, 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 so x cubed in the bottom, x, x, x squared in the top. So that's true. So right now, I'm thinking I'm probably done. So let's just check against our whole to make sure. So my whole is at x equals 2, right? So I'm going to go back and I'm going to plug in a 2 to these leftover factors to see if I get a y value of 0.5. So 2 minus 1 over 2, 2 minus 3. Do I get a y value of 0.5? This is positive 0.5. This is negative 0.5. Okay? So something needs to be negative. There will be times, there are ways to figure out if you need a negative or not. The easiest way is by checking against your whole. This was one of those things somebody asked it on the Facebook group last week. Like, how do we know that's supposed to be negative? And everybody that commented said, check it against your whole. If you plug in your whole and you get the wrong y, is it? And so if I try that, negative 2 minus 1 over 2, 2 minus 3, it does give us 0.5. Okay, so there's not a good, easy, like, this is always how you check it, or always how you know if you have a negative or not. just check it against your whole. Or another point, really, you could probably do. But your whole is kind of a good go-to spot to do that. Now, the one type of asymptote that we briefly skimmed over was a slant asymptote. Okay. And the only thing that you know so far is that a slant asymptote happens when your degree in the numerator is exactly one more than the degree in the denominator. And you know that line, the slant asymptote, is parallel to 5/2 x, but you don't know the exact equation of that line. Well, here's how you find that exact equation. You actually divide out the polynomials, and we get to do that with long division. I had to go back and teach myself doing long division. I've always taught synthetic division. That's where we did it in Algebra 2. It was super quick and easy. You put your number here, and you had 3, 4, 5. You remember doing something like that? Algebra 2, we did it in quadratics. No, we did it in Unit 6. So, for some reason, we have to learn long division. I honestly don't know why, but we're going to. So, it's interesting. So, first, let's practice just dividing normal numbers using long division. You learned in elementary school. So, if I am dividing 676 by 21, I'm going to set this up where the 676 is on the inside, the 21 is on the outside. And then we are okay, well, I take 67 and I divide that by 21. So my first step is to kind of divide. How many times will 21 go into 67? How many? 3. So I put a 3 up here. Okay. And then when I'm doing long division, what do I do with that 3? You multiply. We take the 3 and we multiply it by the 21. And I get what? 63. And we put that there. And then we subtract. And I get 4. We subtract and bring down, right? Bring down the 6. And then I go back and I repeat. So how many times will 21 go into 46? 2. 21 times 2 is 42. And then we subtract. And if I have nothing else to bring down, what do I call the 4? That's my what? Remainder. Right. So when I get done, I can say, okay, well, my quotient is 32 with a remainder of 4. And what that means is that I have 32 plus 4 over 21. So you have 32 and you have 4 out of 21 left over. And you learned that process forever ago and you probably forgot it and moved on. That same process we follow when we're dividing polynomials. But it is a little bit more confusing. Okay. Alexis, did you do this in advanced topics?
I think so.
Probably. I think he's that's the only class that it's really in. Because I'm I'd rather do synthetic division is easy. Maybe synthetic division doesn't always work. I don't know. Anyway. So I have 6x squared plus 7x plus 6. So your numerator goes underneath the little box thing, and then the 2x plus 1 goes out there. Now, you're going to have to pay close attention. So what you do is we start out by dividing. What we divide, we only divide the front, like the leading term. So 6x squared divided by 2x. What is 6x squared divided by 2x? $3x, right? If I have, I'm going through a lot of these today. 6x squared divided by 3x. 6 divided by 3 is 2. X squared divided by x, you basically subtract your exponents, and you have x. Okay. So it's 3x. So we put that up here. So that's my divide step. And then we multiply. We take this 3x and we multiply it by the whole thing. So 3x times 2x. What is 3x times 2x? 6x squared. 3x times 1. 3x times 1 is what? 3x. So I put plus 3x. Okay. So that's my multiply. And then I subtract. We're going to subtract and bring down. So when I subtract, what's 6x squared minus 6x squared? Nothing. What's 7x minus 3x? 4x. And then bring down plus 6. And then I go back through that process again. So I take my leading term divided by this leading term. What's 4x divided by 2x? 2. It's 2. So plus 2. So leading term divided by leading term, and then we get 2, and then I multiply. 2 times this whole thing. What's 2 times 2x? 4x. 2 times 1? 2. So and then I subtract. 4x minus 4x is nothing. They cancel. 6 minus 2 is 4. Is there anything else to bring down? No. So my quotient is 3x plus 2 with a remainder of 4. So my final answer is 3x plus 2 plus 4 over 2x plus 1. So you put your remainder over whatever you were dividing by. It's a lot. I think once I got through a couple examples, like I could just go through the process and it's not so bad. But you have to get through a few examples until you get to that point. Alright, so let's go down to this next example. I don't know why I don't have any question numbers on any of these. Alright. 30x squared plus 11x minus 18. And I'm dividing that by 6x minus 5. First thing we do is take this leading term divided by this leading term. 30x squared divided by 6x is what? 5x. 30 divided by 6 is 5. X squared divided by x is x. And then I take that 5x and go back and multiply it by the whole thing. So 5x times 6x is 30x squared. And 5x times negative 5 is negative 25x. Okay. So then we subtract. 30x squared minus 30x squared cancels out. 11x minus negative 25x. That's really 11 plus 25, which is what? 36x. Don't forget that you're subtracting 11 minus negative 25. And bring down. Alright. Then we repeat. I take my leading term divided by this leading term. 36x divided by 6x is what? 6. Okay. Then I multiply the 6 times everything here. 6 times 6x is 36x. 6 times negative 5 is negative 30. And then we subtract. 36x minus 36x cancels out. Negative 18 minus negative 30 is what? 12. Good. And there's nothing else to bring down, so I'm done. My final answer is 5x plus 6 plus 12 over 6x minus 5. I'm going to let you try this next one. There's something else. So here's what I got. 8x plus 10 plus 11 over x minus 3. Anybody else get that or get close to that? Any questions? We're going to keep doing some more practice. But I want to kind of point out how that affects the slant asymptote. So whenever you do your long division, your slant asymptote, it's the quotient part without the remainder. That gives you the equation of your slant asymptote. So like for example on this last one that we did, I would have a slant asymptote, the line y equals 8x plus 10. So that's like a really steep line. That would have a slant asymptote there. And remember, you only have a slant asymptote if your numerator degree is exactly one more. So you won't, if you do polynomial long division and you end up with like an x squared in your quotient, that's not a slant asymptote. X squared is a parabola, a U shape. That one didn't have a slant asymptote. Okay, so we're going to keep going. But I'm specifically now asking you for the equation of the slant asymptote, so you'll leave off the remainder. So we've got 6x squared plus x plus 5 divided by 2x plus 1. And then I say 6x squared divided by 2x is 3x. And then I multiply the 3x back in. 3x times 2x is 6x squared plus 3x. And then I subtract. So 1x minus 3x is negative 2x. Bring down the plus 5. Negative 2x divided by 2x is negative 1. And so I get a remainder of 6, which doesn't really matter here. My slant asymptote is the line y equals 3x minus 1. Try the next one. So I get your slant asymptote has the equation y equals 7x plus 6. Any questions on that one? Okay. Now this last one, I made this note, but then I just now went back and checked it. So far, all the ones we've done actually could not be factored. These can. So if you factor them, and this one would have a factor that cancels out. This one has a whole. If you factor that and cancel it out, you can do the long division with the original problem, and you can do the long division with the factored out problem. Either one would give you the same equation for a slant asymptote, but your remainder would be different. But for the slant asymptote, your remainder, it doesn't matter. So I'm going to show you how to do it with the whole thing. And we'll get the same slant asymptote. It might be a little bit, I don't know if it's any harder this way or not. We'll see, you can tell me if you think it's harder. But I tested it out both ways, and you get the same slant asymptote. So this one, I have x cubed plus 4x squared minus 12x. You always want to put a 0 if you're missing a term. So if I had been missing the x squared, I would need to put a 0 in its space. I'm missing a plain number at the end, so I'm going to put a 0 there. And then dividing that, it'd leave enough room. X squared plus 7x plus 6. The process is still the same. We still say, okay, this leading term x cubed divided by that leading term x squared. What is that? What? X. Yep. And then I'm going to multiply. X times x squared is x cubed. X times 7x is 7x squared. And x times 6 is 6x. And then I subtract. Those cancel. 4 minus 7 is negative 3. Negative 12 minus 6 is negative 18x. Bring down the 0. And then negative 3x squared divided by x squared is what? Negative 3. And then I multiply. Negative 3 times x squared is negative 3x squared. Negative 21x. Negative 18. And we subtract. And we get 3x plus 18. There's nothing else to bring down. So that whole 3x plus 18 would be your remainder. Okay. And then my slant asymptote is y equals x minus 3. Okay. You could have factored out first and you would have just had fewer numbers to work with. Would be the only difference there.